Sometimes I think about size in ways that break something inside me. Not in a scary way, but in a way that feels like standing at the edge of something so vast that your mind just stops trying to measure it. And that is where we need to start with this story. Not with time, not with mystery, but with the sheer impossible weight of one object sitting out there in the dark. There is something called TON 618. It is a black hole. Most of what we know about black holes comes from smaller ones. We find them scattered through space, and they are terrifying in their own way. But TON 618 is different. It exists at a scale that makes other black holes look like dust. And when I think about it, I feel something shift in my chest. Let me try to help you feel what I mean. Imagine Earth. Hold it in your mind for a second. That blue marble with all of us on it, spinning quietly. Now imagine shrinking it down to the size of a marble you could hold in your hand. Something you could roll across a table. Now imagine taking the sun. That massive burning ball of hydrogen and helium, and shrinking it the same way. The sun is 1,309,000 kilometers across. That is the actual sun. But in our marble scale, it becomes something you could fit in a room. Something you could almost wrap your arms around. Now we get to TON 618. If you kept that marble Earth and that shrunk sun in that same scale, TON 618 would be bigger than the orbit of Neptune, bigger than the entire solar system as we know it. And I need you to sit with that for a moment. Sit with it. Really feel it. Because most of the universe is empty space. Most of it is nothing. And yet this one thing, this one black hole, would contain our entire neighborhood. All 8 planets, the asteroid belt, all the comets and dust and rocks, everything we have mapped and measured in our solar system would fit inside its boundary, and it would still have room and silence. And that silence is important. That emptiness is the thing that makes TON 618 so hard to understand. It is not full. It is compressed. Utterly and completely compressed. The biggest thing humans built is the International Space Station. It is 456 meters long. A commercial airplane is about 70 meters. The distance from where you are right now to the farthest you have ever traveled in a car probably took hours. And TON 618, in this shrunk-down version of our universe, is so big that it would take light, the fastest thing that exists, about 4 hours to travel from one edge of its event horizon to the other. Light, the thing that defines speed itself. Think about that. Light cannot cross it faster. Nothing can. The event horizon is the edge, the point of no return. Once something crosses that line, not even light can escape. And TON 618 event horizon is approximately 236 billion kilometers across. That number probably does not mean much to you. Numbers this big stop feeling real. They become just symbols, just marks on a page. But let us put it differently. The distance from Earth to the Sun is 150 million kilometers. We call that one astronomical unit. It is how we measure everything in our solar system. TON 618 event horizon is 1,570 times wider than that distance. Imagine being able to fit 1,570 Earths in a line between here and the Sun. Now imagine a circle so big that you would need to repeat that line over and over to trace its edge. That is the outer boundary. That is where the point of no return begins. That is where gravity says, you cannot escape. And the mass. The mass is what really makes me feel small. TON 618 weighs approximately 66 billion times what our Sun weighs. 66 billion. If you stacked 660 billion suns on top of each other, they still would not equal TON 618, and this is not spread out. This is not distributed across a galaxy or a nebula or anything loose. This is all concentrated in one place, in a singularity. In a point so small that physics itself does not know how to describe it. All of that weight, all of that gravity, all of that pull compressed into a single point so dense that space itself bends around it like fabric around a hole. We have a category for black holes based on their mass. Stellar black holes come from dead stars. They are maybe 5 to 20 times the mass of the Sun. Then we have supermassive black holes, which sit at the centers of galaxies. They are millions or billions of times the Sun weight. We thought that was the biggest thing possible. We built our understanding of the universe around the idea that supermassive was the top of the scale. We thought we understood the rules. And then we found ton 618. And the word supermassive was not big enough anymore. There is a word now called ultramassive, and ton 618 does not just fit into that category. It sits at the extreme edge of it. It is the heaviest black hole we have ever found. Not by a little bit. Not even by a lot. By an amount so large that it changes how we think about what is possible. The gravitational reach of something this massive is something that keeps me awake at night, actually. Gravity does not have a wall where it stops. It just gets weaker the farther away you go, but it never truly stops. And ton 618 is so heavy that its gravity would still be noticeable from incredibly far away. Imagine standing on the surface of your planet. The gravity holding you down. The force that makes your feet press into the ground. That is your planet gravity. Now, imagine walking to the edge of the solar system. Pluto is still quite close, relatively speaking, but if you are far enough away that ton 618 is just a pinprick of light in the sky, you would still feel the slightest pull. Like a whisper. Like the gentlest hand on your back, saying come closer. And if you got closer, that whisper would become a firm grip. And if you got even closer, nothing in the universe could save you. Nothing. Not rockets. Not physics. Not even light itself could help you. You would just fall. And keep falling until you cross the event horizon, and then you would be gone. There is something almost beautiful about understanding that you are safe because you are far away. That the universe is so big and so empty that even though ton 618 exists pulling on everything around it, we are separated by so much distance and so much time that we can only know it through its ancient light. Light that left when the universe was young. Light that has been traveling through the void for billions of years to reach our eyes. And that brings us to the strangest part of all this. Ton 618 is the single largest gravitational object we have ever observed. But it is also one of the oldest. It is not something that was born recently in cosmic time. It was already impossibly huge when the universe was young, and that fact, that simple fact, breaks everything we thought we knew about how the universe works. Because the universe simply has not had enough time to grow something this big through normal means. And that is where our real mystery begins. But for now, for right now, just sit with the size of it. Sit with the fact that out there in the dark billions of light years away, there is a thing so massive and so old and so utterly immense that it bends space and time around itself like nothing else in existence. Let me take you somewhere that does not exist anymore. Or rather, it exists now, but only as light. Only as the memory of what it was 10 billion years ago. And that is what ton 618 really is. It is a time machine in the most literal sense possible. Not because it can travel through time, but because of how long the light from it has taken to reach us. When we see ton 618, through our telescopes, we are not seeing what it is right now. We are seeing what it was when the universe was much younger. 10.4 billion years younger to be precise. And that difference matters. It matters in ways that change everything about how we understand what we are looking at. So when we talk about this black hole, we are really talking about history. About the universe when it was young. About what existed before most of the things we know. 10.4 billion years is hard to hold in your mind. So let me try this. The universe is about 13.8 billion years old. That means when the light we are seeing now left ton 618, the universe was only 3.4 billion years old, barely a quarter of its current age, still in its childhood, still hot, still wild, still figuring out how to make galaxies and stars and planets. Back then, the universe was smaller, not in the sense of having edges, but in the sense that everything was closer together. The space between galaxies had not stretched as much. Matter was denser. Gas clouds were thicker. Stars were forming faster. And the whole cosmic web was tighter, more compressed. It was a different place. Not just earlier, different. Scientists use something called redshift to measure distance and time. When light travels through expanding space stretches the light. Like pulling a spring, the wavelengths get longer. And longer wavelengths mean the light shifts toward the red end of the spectrum. The farther something is, the more its light is redshifted. Ton 618 has a very high redshift, which tells us it is incredibly far away and incredibly old. But redshift is more than just measurement. It is a kind of archaeology. Every photon carries information about when it was made, about the conditions it traveled through, about the universe at that time. So when we look at red-shifted light, we are not just seeing distance, we are seeing time. The farther we look, the farther back we go. And with ton 618, we are looking back to an era that no longer exists anywhere. An era that has passed, transformed, become something else entirely. This time is called the epoch of reionization. Before this, the universe was dark, full of neutral hydrogen gas, but no stars to light it. Scientists call that period the cosmic dark ages, not because anything bad was happening, just because there was no light, no stars, no visible light sources at all. The first stars had not formed yet. The first galaxies had not gathered. Everything was cold, neutral, waiting in silence. But then the first stars ignited, massive stars, bright and hot. And their ultraviolet light began to split hydrogen atoms apart, ionizing them, turning neutral gas into charged particles, and slowly light spread through the universe. Like dawn breaking over a dark planet. Regions of ionized gas grew, merged, overlapped. And the cosmic dark ages ended. The universe woke up. And ton 618 was there, right at that transition, right at the boundary between dark and light. I find that beautiful, the idea that this black hole witnessed the universe lighting up. That it was there when the first stars turned on, when the darkness began to fade. Ton 618 was already massive by then, already pulling, already shaping the space around it. A giant in the dawn. And the light that left it back then has been traveling ever since. Moving through the expanding cosmos, passing young galaxies, passing regions where stars were being born and dying. Passing clouds of gas that would later become planets. Passing through time itself. The light did not stop, did not slow, it just kept going, carrying its information, its timestamp, its message, traveling through a universe that was constantly changing, constantly evolving, but the light itself remained constant, unchanging, a perfect record of what ton 618 was like billions of years ago, When that light finally reached us, we caught it with telescopes. We measured its spectrum, its brightness, the way it flickered, and from those measurements we built a picture. Not a clear image, but a model, a reconstruction. We learned how massive the black hole is, how bright it was, how fast it was eating. All from light that left 10 billion years ago. We learned about the universe it inhabited, about the conditions around it, about what was happening in that ancient cosmos. And through that knowledge, we could reach back through time and touch the past. Or at least sense it. Feel its presence. Understand something about what it was like. The loneliness of that time is hard to describe. The universe was so much emptier then, fewer galaxies, fewer stars, fewer places where complexity could grow. The space between things was vast, cold, mostly dark. And yet here was Ton 618, a giant, sitting in the early universe, pulling everything nearby into itself. A single massive point in an ocean of near emptiness, but it was not silent. Gas was falling in, forming a disk around the black hole, heating up from friction, glowing, and that glow was brilliant, brighter than entire galaxies. Ton 618 was a quasar, a beacon, one of the brightest objects in the early universe, and anything nearby would have seen it, felt it, been pulled toward it. The light we see now is faint, because it has traveled so far, because the universe has stretched it, redshifted it, diluted it. But when it left Ton 618, it was fierce, intense, a flood of energy pouring out from the accretion disk, heating matter, accelerating particles, sending beams of radiation out into space. And that brightness tells us something. It tells us the black hole was active, feeding, growing, that it was not a dormant object, but a dynamic one. A living thing in its own way, eating and growing and reshaping its environment. So we have this strange connection across time. We are looking at something that no longer exists in the form we see. By now 10 billion years later, Ton 618 has probably changed. Maybe grown larger. Maybe gone quiet. Maybe it ran out of nearby gas and now sits dormant. Waiting. Pulling things in with its gravity, but no longer shining with that quasar light. We cannot know. Because the light showing us the present has not arrived yet. It will not arrive for billions more years. We are always looking backward, always seeing the past, always separated from the present by the speed of light and the vast distances of space. But that is true for everything in the sky. When you look at the moon, you see it as it was 1 second ago, the sun as it was 8 minutes ago, the nearest star as it was 4 years ago. Distance equals time. Light has speed, and speed means delay. So the farther we look, the older the view. And Ton 618 is so far that we are seeing the universe as it was in its youth. And maybe that is the real gift. Not just knowledge of the black hole, but knowledge of time, of history. Of the journey light makes to reach us. Of the universe as it was before we were here, before Earth formed, before our sun ignited, before any of this happened. And that knowledge is precious, because it tells us that we are part of a story. A long story. A story that started billions of years ago in ways we are only beginning to understand. And Ton 618 is one of the oldest characters in that story. There is a problem with Ton 618. It should not be possible. Not this big. Not this early. Not with the rules we know. The math breaks down. And when scientists find something that breaks the math, they do not panic. They get quiet. They get curious. because the universe does not lie. If something exists, it must be possible. So either the thing is different than we think, or the rules are incomplete, or we are missing something fundamental. Let me explain the problem. Black holes grow by eating. They pull in gas, stars, dust, anything that wanders too close, and as they eat they get heavier. Heavier means stronger gravity. Stronger gravity means they can pull from farther away. So the process feeds itself. The bigger you are, the faster you grow, like compound interest, like snowballs rolling downhill. But there is a limit, a speed limit. Scientists call it the Eddington limit. And it works like this. When matter falls toward a black hole, it does not just vanish instantly. It forms a disk, an accretion disk, swirling around the black hole. And the friction in that disk heats the matter up, makes it glow, makes it hot, very hot, and hot things radiate. They push back with light, with pressure, and that pressure works against gravity. It tries to stop more matter from falling in. So there is a balance, a tug of war. Gravity pulls in, radiation pushes out, and the Eddington limit is the point where they are equal. The maximum rate a black hole can eat without choking. If it tries to pull in more, the radiation blows the matter away. The black hole has to wait, has to eat slowly. There is no cheat code, no shortcut, no way around it. And this is where ton 618 becomes impossible. Because even if it ate at the maximum rate every single moment for 3.4 billion years, it still would not be big enough. The numbers do not work. You cannot grow a black hole to 66 billion solar masses in that amount of time, starting from a normal seed. Not with the Eddington limit in place. The math just does not close. Think of it like filling a swimming pool with a garden hose. The hose has a maximum flow. You cannot make water come out faster. And if the pool is enormous, there just is not enough time. Even if you run the hose non-stop day and night, for years the pool will not fill. And if someone tells you it did fill, you know something is wrong. Either they are wrong about how big the pool is, or they are wrong about how long the hose has been running, or the hose is bigger than they think. Something does not add up. Ton 618 is that pool. The Eddington limit is the hose, and 3.4 billion years is the time we have. The math does not close. Scientists ran the calculations backward. If ton 618 weighs 66 billion suns now, and it had 3.4 billion years to grow, how heavy did it have to start? And the answer they got was shocking. Even if it started as a black hole weighing 100,000 suns, it still would not be enough. Even 1 million solar masses at the start would not be enough. It would need to begin even heavier, or eat faster than the limit allows, or both. And that creates the paradox. Because black holes cannot eat faster than the Eddington limit. Physics forbids it. The radiation pressure is real. The pushback is real. We have measured it in other black holes. It is not negotiable. It is not something that can be worked around. But ton 618 exists. We see it. We measured its mass. We took spectra. We analyzed its light. So something is wrong. Either our measurements are off, or our models of black hole growth are incomplete, or ton 618 had some kind of advantage we do not understand yet. This is not just about one object. There are other ultramassive black holes in the early universe too. Not quite as large, but still too large for their age. Every time we find one, the mystery deepens, because it suggests this is not a fluke, not an error, not a single anomaly. It is a pattern. The early universe was somehow producing black holes that should not exist yet. And that means we are missing something. Something important. something that changes how we think about black hole formation. There are a few ideas. Maybe the Eddington limit can be broken under special conditions. If the gas falling in is very cold, very smooth, very dense, maybe it falls straight in before it has time to heat up and push back. That would allow faster growth. But we have not seen clear evidence of this, and it will require very specific conditions, very specific situations that would need to happen over and over. Or maybe the black holes were fed differently. Maybe instead of eating randomly, they had direct pipelines. Streams of gas flowing in from the cosmic web, like a fire hose instead of a garden hose. More matter per second, more fuel. That would help. That would speed things up. But the Eddington limit still applies. You can only push so much through the door before the pressure builds, before radiation begins to push back, before the system reaches equilibrium and stops accelerating. Or maybe Ton 618 started heavier than we think. Maybe it did not form from a single dying star. Maybe it formed some other way. Skipping the small phase entirely. Jumping straight to massive. Born big instead of growing big. And if that is true, then the whole question changes. Because then we are not asking how it grew so fast. We are asking how it was born so heavy. This idea shifts the mystery backward in time. Instead of focusing on growth, we focus on origin. And origin is harder to study, because it happened so long ago. In conditions we can never recreate, in an era we can only see through distant light. But it is also more interesting, because if Ton 618 was born massive then, the early universe was capable of things we did not think possible. And honestly, I find this beautiful. The fact that we can still be surprised. That even with all our telescopes, all our equations, all our models, all our understanding, we can still find something that makes us stop and say, wait, how did that happen? The universe does not owe us easy answers. It does not have to fit into our theories. It just is. And we have to catch up. Ton 618 is a teacher. It is showing us the edge of our knowledge, not to frustrate us, but to invite us further, to say there is more here. Keep looking, keep thinking. Do not settle for the simple story. Because reality is wilder, stranger, more creative than we imagined. So what is the answer? How did Ton 618 get so big so fast? The truth is we do not know for certain, but we have a hypothesis, a possibility. And it takes us back to the very beginning, to the first fraction of a second after the Big Bang, to a time when the universe was not just young, it was brand new. And maybe in that newness something happened, something that planted the seeds for giants, something that made Ton 618 possible, something that the universe has been trying to tell us all along. What if black holes do not all start the same way? What if some are born instead of made? What if Ton 618 did not grow from a dying star? What if it was already there at the very beginning, waiting, pulling, already massive, already shaping space? Born in the chaos of the Big Bang itself, not from matter collapsing, but from the universe itself, from density, from energy, from the raw ingredients of existence. This is the idea of primordial black holes, and it changes everything. Because if Ton 618 is primordial then, it did not have to race against time. It started the race ahead. It began life already heavy, already past the slow early stages, and that solves the paradox. Because the clock does not start when a star dies, it starts at the beginning of time. At 0 seconds. And from there, 3.4 billion years is plenty. More than plenty. The idea is not brand new. Stephen Hawking explored it back in the 1970s. He was studying the very early universe, the first moments, the first fractions of a second, and he realized that the conditions back then were extreme. Density was enormous, pressure was unimaginable. And in that environment, space itself could collapse. Tiny regions, pockets of density, could pinch off and become black holes, not from stars, not from the death of massive objects, from the fabric of space-time itself. A primordial black hole, born not from stellar collapse, but from quantum fluctuation. Hawking originally thought these primordial black holes would be tiny, microscopic even, quantum-sized, and he predicted they would evaporate quickly, giving off radiation, fading away in a flash. But what if that was only part of the picture? What if some primordial black holes were not tiny? What if under certain conditions some regions collapsed into massive black holes, heavy seeds, already weighing thousands, millions, maybe even billions of solar masses? Right from the start, this is the shift, the new possibility. What if in the wild chaos of the Big Bang some fluctuations were so dense, so extreme, that when they collapsed they did not form small quantum holes, they formed giants. Seeds that could grow over billions of years into something like ton 618. The math allows it. In the first fraction of a second after the Big Bang, the universe was unimaginably dense. Everything that would become galaxies and stars and planets was compressed into a space smaller than an atom. And in that compression there were ripples, fluctuations, quantum jitters in the density field. Some places slightly more dense, some slightly less. And if one of those dense spots was heavy enough, it could collapse under its own gravity. Before the universe expanded enough to stop it, and when it collapsed it would form a black hole. This is completely different from how normal black holes form. Normal black holes come from stars. A massive star burns for millions of years, runs out of fuel. The core collapses, the outer layers explode in a supernova. And what remains is a black hole. Usually between 3 and 100 solar masses. That is the standard path. Star, death, collapse, black hole. But primordial black holes skip all that. They do not need stars. They do not need fusion. They do not need time to evolve. They form directly from the structure of space-time, from density itself, and they can form at any mass, depending on the size of the fluctuation. Tiny ones, medium ones, maybe even supermassive ones, all in the first second. If ton 618 is primordial, it means it has been around since the beginning. It did not wait for stars to form. It did not wait for galaxies to gather. It was already there, sitting in the infant universe, a giant in a sea of hydrogen, and all it had to do was wait and eat and grow, starting from a head start so large that reaching 66 billion solar masses was not impossible, just patient. The beauty of this idea is that it solves the time problem. If ton 618 started with a mass of say 10 million suns, then growing to 66 billion is much easier. It only needs to multiply by about 6,000. That is still huge growth, but with 3.4 billion years and steady feeding at the Eddington limit, it is achievable. The paradox disappears. The mystery resolves. But there is a catch. We have never directly observed a primordial black hole forming. We have never seen one in the act of creation. All we have is theory, equations, models, and the puzzling fact that black holes like ton 618 exist when they should not. That is not proof. It is evidence, circumstantial, suggestive. but not definitive. Still, the hypothesis feels right. It feels elegant, because it takes an impossible problem and makes it possible. Not by bending the rules of physics, but by changing the starting conditions. And starting conditions matter. A tiny seed and a giant seed face very different futures, even if they follow the same rules. A tiny seed needs time to grow, centuries, millennia, eons. A giant seed only needs patience. It is already heavy, already capable, already on its way. And if this is true, it tells us something profound about the early universe. It tells us that the Big Bang was not smooth, not uniform. There were lumps, wrinkles, places where density spiked. And those spikes had consequences. They became the seeds for structure, for galaxies, for clusters, and maybe for supermassive black holes. Ton 618 might be a relic, a survivor from the first second, a fossil of creation itself. And if we look at it that way, it becomes more than just a black hole. It becomes a messenger, a piece of evidence from a time we cannot visit, cannot recreate, can only study through math and distant light. It becomes a witness to the beginning, and maybe that is the real gift. Not just the mystery, but the invitation, the reminder that the universe has history, deep history, and that history shaped everything, including us. We are made of atoms forged in stars, stars that formed in galaxies, galaxies that grew around black holes that might have been born in the Big Bang. Everything connects. Everything reaches back to the beginning. So when we look at Ton 618, we are not just looking at a massive object. We are looking at time, at origin, at the question of how things begin. And that question is one of the oldest, one of the deepest, one we have been asking since we first looked up at the sky and wondered where it all came from. And maybe Ton 618 is part of the answer. Maybe it is a piece of the puzzle. Maybe it is telling us something that we have not yet learned to listen to. Something that the universe has been trying to tell us all along. Let me take you back. Back before stars. Before galaxies. Before atoms. Before light could travel freely. Back to the very first moment. The beginning. The instant when everything started. Not from nothing. We do not know what came before. Maybe nothing. Maybe something else. Maybe something we have no words for. But at time equals zero, the universe as we know it began. It was not a place. It was not an explosion in space. It was space itself, and time, and energy, all coming into existence together, expanding, cooling, changing. And in that first second more happened than in all the billions of years that followed, because the rules were different then. The universe was hotter, denser, more extreme, and in that extremity lay the seeds of everything. Picture this if you can. The entire observable universe. Every galaxy, every star, every planet, every atom, every electron, everything. All of it compressed into a region smaller than a single atom. The density is beyond imagining. The temperature is beyond measuring. It is a state called the Planck epoch, a soup of pure energy. No particles yet, no structure, just raw potential. Existence at its most fundamental, and in that soup there were fluctuations. Quantum fluctuations. Tiny ripples in the energy field. Some spots slightly denser, some slightly less. These ripples came from quantum uncertainty, the natural jitter at the smaller scales. The uncertainty principle made manifest, and normally they would be insignificant. Random noise, background static. But here at the beginning they mattered, because when the universe began to expand, those ripples got stretched, amplified, frozen into the structure of space. Most of those ripples stayed small. They became the seeds for galaxies much later. The tiny variations that grew into the large-scale structure of the universe, but some, a rare few, were extreme. Dense enough that gravity took over immediately, and when gravity takes over in a region that dense, there is only one outcome: collapse. The region folds in on itself. Space-time curves, and a black hole forms, not from matter, from energy. From the structure of space itself, a primordial black hole, born not from a star but from the Big Bang itself. This happened fast, in the first fraction of a second, before the universe was even 1 second old. Before quarks combined into protons, before electrons existed, before light existed, before atoms could form, in that brief wild moment, some pockets of space-time collapsed and became black holes. And those black holes did not evaporate. They were stable, permanent, and they have been here ever since, growing, waiting, shaping the universe around them. Ton 618 might be one of those. A fluctuation that collapsed in the first instant, born not from a star, but from the Big Bang itself. And if that is true, then its mass was set at birth. Maybe it started with 1 million solar masses, maybe 10 million, maybe more. We do not know. We cannot see that far back. But we can infer. We can work backward from what we see now and imagine what it must have been then. The early universe was strange. For the first few 100,000 years, it was opaque, filled with hot plasma. Light could not travel freely. It scattered off charged particles, bounced around, like walking through thick fog. The universe was like a thick fog, glowing, but you could not see through it. And in that fog, the primordial black holes sat, invisible, pulling, growing, feeding on the plasma around them. The matter was hot and dense and swirling, and anything that got too close to a black hole would fall in, would be consumed, would become part of it, and the black hole would grow. Then the universe cooled. The plasma turned into neutral hydrogen gas. Light could finally travel. The fog cleared, and the universe entered what scientists call the Dark Ages. No stars yet, just gas. Cold, neutral, spread thin across expanding space. But the silence was not empty. The darkness was not nothing. The primordial black holes were still there, still pulling, still growing, but slowly now. Because the gas was thin, spread out, not much to eat. But Ton 618 had an advantage. It was already massive, and massive things have strong gravity. Strong gravity pulls from farther away. So even in the thin dark gas, Ton 618 could gather streams. Filaments from the cosmic web, invisible channels of hydrogen flowing in, guided by gravity, pulled inexorably toward the black hole, and slowly, steadily the black hole fed. Millions of years passed. The Dark Ages continued. Ton 618 grew heavier, and then something changed. The first stars formed. Massive, bright stars, born from collapsing gas clouds, and those stars ignited. Fusion began. Light poured out, and the universe began to wake up. The Dark Ages ended. Reionization began, and Ton 618 sat at the edge of that transition, a giant in the dawn, already enormous, already pulling, already shaping the space around it. By the time the universe was a few 100 million years old, Ton 618 was well established. Maybe not yet 66 billion solar masses, but large enough, heavy enough, dominant enough. And it continued to grow. The hydrogen flowed in, heated up, formed an accretion disk, and the disk began to glow, brighter and brighter, until Ton 618 became a quasar, a beacon, one of the brightest objects in the young universe. And all of this, all of it, traces back to that first second, to the quantum fluctuation that collapsed, to the density spike that became a black hole. That moment set everything in motion. The growth, the feeding, the light, the gravity. Everything we see now when we look at Ton 618 is the echo of that first instant, the result of a creation event that happened before time had meaning. I find that almost overwhelming. The idea that something so massive, so present, so real, could come from something so brief, a fraction of a second, a ripple in energy. And yet, here it is, still existing, still pulling, still teaching us about the beginning. If Ton 618 is primordial, then it is one of the oldest objects in the universe, older than stars, older than galaxies, a relic from the first moment. And looking at it is like looking at a fossil, not of life, but of creation itself, of the instant when the universe began and anything was possible. And maybe that is the real story. Not just how Ton 618 grew, but how it began. Because beginning matters. Origin shapes destiny. And if this black hole was born in the Big Bang, then it carries information we can find nowhere else. Information about the early universe, about density, about quantum fluctuations, about the conditions that allowed giants to form. But wait, there is another way, another possibility. Another story that could explain how Ton 618 came to be, because science does not settle on one answer easily. It keeps asking questions. It keeps exploring alternatives. It keeps looking for the truth in multiple directions. And there is a theory that sits alongside the primordial black hole hypothesis. It is called the direct collapse scenario. And it offers a different path, a different journey, a different way for a giant to be born in the early universe. So let me tell you about this other possibility, because it matters. Because it shows that even when we think we have found the answer, there might be something else waiting in the shadows. Imagine the early universe, maybe a few million years after the Big Bang. The dark ages are still happening. There is no starlight yet. But the universe is not completely dark. There are clouds, massive clouds of hydrogen gas. Some of these clouds are ordinary. They will eventually collapse and form stars. Billions of stars. But some of these clouds are different. Some are extraordinarily large. Supergiant gas clouds, so massive that they cannot follow the normal path. They are too big, too heavy, to become stars. Because stars have limits. They can only be so big before they tear themselves apart. Before the gravity becomes so strong that the hydrogen atoms fuse too fast and the star explodes. There is an upper limit to stellar mass. Maybe a few hundred times the mass of the Sun. Maybe 1,000 at most. But these clouds are bigger than that. Much bigger. So when they try to collapse, what happens? They do not become stars. They cannot become stars. They are too massive. The normal process breaks down, and instead of igniting fusion, they do something else. They collapse directly. All the way down, straight into a black hole, without ever burning hydrogen, without ever becoming a star, without any intermediate step. This is the direct collapse. The silent implosion. The cloud folds in on itself and becomes a black hole. And that black hole is born already massive, because it contains all the mass of that gigantic cloud, instantly, in one moment. From cloud to black hole, skipping the stellar phase entirely. Think about what that means. Imagine a cloud of gas, so large that it spans billions of kilometers, filled with enough hydrogen to make thousands of normal stars. And then imagine all of that collapsing, not slowly over millions of years, but quickly, directly, in a gravitational cascade that cannot be stopped, cannot be slowed. The pressure builds, the density increases, and before any fusion can begin, before any nuclear reaction can start, the entire thing crosses the point of no return, and a black hole is born. A black hole that is already millions of times heavier than the Sun. Born not from stellar death, but from the direct collapse of a supergiant cloud. And this is where atomic cooling becomes important. Because there is a reason these clouds cannot become stars. The reason is cooling. When a normal gas cloud collapses, it heats up. The gas compresses and the temperature rises. And when the temperature gets high enough, fusion begins. The cloud ignites and becomes a star. But these supergiant clouds are different. They have a special property. They are made mostly of atomic hydrogen. And atomic hydrogen has a particular ability. It can radiate heat very efficiently. It can emit radiation that carries energy away, cooling the gas. And when the gas cools, it cannot support itself against its own gravity. It cannot build up enough pressure to resist the collapse. So it keeps collapsing, keeps cooling, keeps getting denser. And eventually, the cooling becomes so efficient that nothing can stop the process. The cloud collapses so fast and so completely that it never has a chance to heat up enough to ignite fusion. It never becomes a star. It just keeps going, straight down into a black hole, the direct collapse. And the key to this is that the cooling is just right. Too much cooling and nothing forms. Too little cooling and a star forms instead. But at just the right balance, in just the right conditions, in just the right era of the universe, these supergiant clouds collapse directly into black holes. And these black holes are heavy seeds, just like the primordial black holes. They are born already massive, already capable of growing into giants, already positioned to become something like ton 618. So maybe ton 618 was born this way. Maybe it started as a supergiant gas cloud in the early universe. Maybe it was surrounded by other clouds that became stars. But ton 618 itself was too big, too massive, and so it collapsed directly, silently, without fanfare, without any bright supernova explosion. Just a cloud becoming a black hole, a cosmic implosion that no one witnessed, that left no trace except the black hole itself. And this scenario has its own beauty. Because it is quiet, it is peaceful. A cloud does not scream when it collapses into a black hole. It does not explode. It does not cry out. It just folds in on itself, becomes something else, becomes something darker, becomes a point where space itself breaks. And there is something almost meditative about that. Something that fits with the quiet tone of this story. Ton 618 might have been born in silence, in the dark, without any drama, without any violence. Just a quiet transformation. A peaceful becoming. A cloud that decided to become something else. But here is the thing. Whether ton 618 was born as a primordial black hole in the first second or as a direct collapse black hole a few million years later, the result is the same. It was born heavy. It had a head start. It did not have to grow from a small seed into a giant. It started out already giant. And that is what matters. That is what solves the paradox. That is what makes ton 618 possible. So we have two paths, two stories. 2 ways that a black hole could become incredibly massive in the early universe. And we do not know which one Ton 618 took. We might never know. But we know that one of them happened, because Ton 618 is here, and it is real. And both of these paths share something important. They both show that the early universe was capable of creating massive black holes without needing billions of years of growth. Without needing the Eddington limit to be broken. Without needing anything impossible. Just different starting conditions. Different physics. Different possibilities. And that is the real message. That the universe is more creative than we thought. That there are multiple ways to make giants. Now imagine 2 black holes. Let us call them Seed 1 and Seed 2. Seed 1 weighs 1,000 solar masses. Seed 2 weighs 10 million solar masses. They exist in the early universe. They exist at the same time. They exist in similar environments. They have access to roughly the same amount of food, roughly the same amount of gas and dust, and stellar material to eat. So they start growing, they start feeding. They eat at roughly the same rate. The Eddington limit applies to both of them equally. The radiation pressure affects them equally. Everything is equal except for one thing: their starting mass. And this is where everything changes. Because black holes do not grow linearly. They do not just add the same amount of mass each year like a person gaining weight. They grow exponentially. They grow like compound interest. And compound interest favors those who start with more. Imagine having $1 versus $10,000 in the bank. Both earning the same interest rate, say 5% per year. The person with $1 gains 5 cents. The person with $10,000 gains $500. Both have the same interest rate, but the person with more money makes more money. And over time, the gap grows. It does not close. It expands. The rich get richer. The poor get poorer, or rather they grow slower. And that is exactly what happens with black holes. Seed 2 grows faster because it is already heavier. Its gravity is stronger. It pulls more efficiently. It captures more of the available gas. And as it grows, it gets even stronger. And its gravity pulls even more. And it captures even more. And the process accelerates. Seed 1 is also growing, but more slowly. It is capturing what it can, but it is capturing less. Less per year. Less per millennium. Less per million years. And the gap between them widens. If you give them 3 billion years, Seed 1 might reach 1 billion solar masses. Seed 2 might reach 100 billion. The heavy seed wins the race. The head start compounds into dominance. This is not because the universe is unfair. It is not because physics has favorites. It is just mathematics. It is how exponential growth works. And Ton 618 had the ultimate head start. Whether it started as a primordial black hole or as a direct collapse black hole, it started heavy. Maybe 10 million solar masses, maybe 100 million. Whatever the number, it was already massive, and from there the compounding could begin. From there the exponential growth could accelerate, and over billions of years that head start could compound into something truly immense. Let me give you the math. If Ton 618 started at 10 million solar masses and grew at the Eddington limit, eating efficiently and steadily for 3.4 billion years, it could reach something like 60 billion solar masses. Maybe 100 billion, depending on the exact conditions. So the numbers work. The head start solves the paradox. The heavy seed explains how the impossible became possible. And this is beautiful in its own way. It is not magic. It is not a violation of physics. It is just mathematics. It is just the way exponential growth works when you start ahead. And this explains something else too. It explains why there might be other ultramassive black holes in the early universe. Not just Ton 618, but others. Galaxies that harbor black holes that are too massive for their age. Because if the conditions were right, if there were density fluctuations or supergent gas clouds in certain regions, then multiple heavy seeds could have formed, multiple direct collapses could have happened. Multiple primordial black holes could have condensed, and each one of them starting from a head start could have grown into something massive. Something that should not exist but does. So when we look at Ton 618, we are not looking at a fluke. We are not looking at an impossible outlier. We are looking at the success story of a mathematical principle. We are looking at compound interest made manifest in gravity and mass, and the expansion of space-time itself. We are looking at a black hole that started heavy and then got heavier and heavier, until it became the heaviest black hole in the universe. The survival of the fittest applied to black holes. The strongest gravitational pull wins the race for food. The most massive object attracts the most material. And Ton 618 was the most massive from the start. And this idea of survival of the fittest is interesting because it suggests something about the early universe. It suggests that there was competition, that different seeds were racing each other, that smaller seeds were trying to grow while larger seeds were pulling material away from them, that the cosmic resources were not infinite, that there was a finite amount of gas and dust available, and the black holes that started heaviest would eat first, would eat most, would starve out the others. And Ton 618 would have dominated. It would have eaten the material in its region. It would have pulled gas from the cosmic web. It would have hoarded the resources, and it would have grown while others around it starved or grew much more slowly. This is not cruelty. This is not intention. This is just physics. This is just the way gravity works. The strongest pulls the hardest. The most massive dominates. And Ton 618 was the most massive. So it won. It grew. It became the heavyweight champion of the early universe, and billions of years later, we can see the results of that victory. We can see a black hole so massive that it breaks our expectations. So old that it challenges our models. So dominant that it has no equal. And we can understand how it got that way. Not through impossible growth, but through a head start that compounded over billions of years. Picture this. The universe is very young, maybe a few 100 million years old. There are still no stars, or very few. The darkness is almost total. Almost overwhelming. And in that darkness, Ton 618 sits, waiting, pulling. It is a giant even then, already millions of times heavier than the Sun. And around it in that dark universe is hydrogen. So much hydrogen, the universe is mostly hydrogen. And that hydrogen is not evenly distributed. It flows along filaments, along the cosmic web. Invisible threads that connect regions of space. And Ton 618 sits at a node in that web, at a junction, where the threads converge, where the gas flows in. And so the feast begins. Not a violent feast, not an explosion, but a slow, steady. Hydrogen flows toward the black hole, pulled by gravity, following the contours of space-time, sliding along the invisible slopes that the black hole creates. And as the hydrogen falls in it accelerates, it heats up slightly, but not too much. Because there is plenty of time, there is no rush. The universe has all of time, and Ton 618 has all the gas it needs. The Dark Ages. This is what we call this era. But there is nothing sad about it, nothing frightening. It is peaceful, it is quiet, it is the universe in its infancy, before the first stars ignite. before light fills the cosmos, before anything complicated emerges. And in that piece, Ton 618 feeds. Millions of years pass, then millions more. And Ton 618 grows, not rapidly, not in the way a quasar grows, but steadily, inevitably. The hydrogen pours in, and the black hole gets heavier, and its gravity gets stronger, and more hydrogen pours in, and the process continues. The cosmic web is feeding it. The universe itself is feeding Ton 618, because that is what the cosmic web does. It channels material. It funnels gas and dust toward overdense regions, and Ton 618 is the ultimate overdense region, the ultimate gravitational sink. So everything nearby flows toward it. Everything in its region of the universe is eventually drawn in, and as Ton 618 grows, it reaches out farther. Its gravity extends farther, and it pulls material from a larger and larger volume of space. Imagine the filaments of the cosmic web as rivers, and Ton 618 as the ocean, and all the rivers flow toward the ocean. Some take quick paths, some take long winding routes, but eventually all the water in the rivers flows into the ocean, and the ocean gets bigger. And when the ocean gets bigger, it can receive even more water. It can accept even more rivers. It becomes the inevitable destination for everything nearby, and Ton 618 becomes the same. It becomes the inevitable destination for all the hydrogen in its region. This is the silent growth. This is the feast that no one sees. Because in the dark ages there are no witnesses, no one watching, no light to record it. The universe is in darkness, and Ton 618 is growing in that darkness. And there is something deeply peaceful about that, something meditative. Ton 618 is not screaming, not raging, not destroying. It is simply existing, simply pulling, simply accepting what the universe offers, and growing, slowly, steadily, inevitably. And the hydrogen that falls in does not all get consumed instantly. Some of it forms an accretion disk. Some of it swirls around the black hole. Some of it heats up. Some of it radiates energy. Some of it eventually crosses the event horizon and is truly gone. But the process is slow enough that Ton 618 can maintain this steady diet, can continue growing without choking, without the radiation pressure building up too much, without the process stopping. The Eddington limit is not breached, but it is respected. Ton 618 eats at the maximum sustainable rate, and that rate is enough to double its mass over millions of years, enough to grow by factors of 10 over tens of millions of years. And all the while the universe is cooling, the plasma is becoming gas. The radiation is spreading out. The universe is expanding. Space itself is stretching. And Ton 618 is growing into that expanding space. It is a strange situation. The universe is getting bigger, and Ton 618 is getting heavier. Both things are happening. Both things are true, and somehow they work together. The expansion of space means there is always more room, always more material far away that can fall in. And Ton 618 takes full advantage. It is the patient hunter, the eternal predator, the gravitational trap that everything eventually falls into. And maybe this is the real nature of Ton 618, not a violent destroyer, but a patient accumulator, not an explosion but an accretion, not a sudden becoming but a gradual growth. The feast happens not in a brief moment but over millions of years. The hunger is not desperate but eternal. And Ton 618 simply exists and grows and accepts what the universe gives it. And in doing so, it becomes one of the largest things in existence, not through violence or force, but through patience, through acceptance, through simply being in the right place and continuing to exist. And maybe that is the deepest lesson of Ton 618, that sometimes the greatest growth comes not from struggle, but from surrender. Not from fighting the universe, but from accepting it, and then something changes. After millions of years of quiet growth, after millions of years of patient feeding in darkness, something awakens. The first stars form. The first galaxies begin to gather. Light emerges. And with light comes energy. And with energy comes change. And Ton 618 changes too. It transitions. It transforms. It becomes something new. It becomes a quasar. And the universe will never be the same. Because the stars that form nearby start burning. They fuse hydrogen into helium. They release enormous amounts of energy. They heat the gas around them. And the gas becomes turbulent, becomes chaotic, becomes compressed. And some of that gas flows toward Ton 618, much more than before. Because the density of the universe is increasing in certain regions. The cosmic web is thickening, material is accumulating, and Ton 618 is in the center of an accumulation zone, a region where stars are forming, where galaxies are being born, where the universe is becoming thick and active. And Ton 618 begins to consume this material at an increasing rate. Faster than before. Not faster than the Eddington limit allows, but approaching that limit. And as the material falls in faster, it heats up more. It glows brighter. And the accretion disk begins to shine, begins to radiate, begins to pour energy out into space. And Ton 618 becomes visible. For the first time since the beginning, it becomes visible. It becomes a beacon, a lighthouse, a source of light in the young universe. This is the quasar phase. And quasars are strange objects. They are not just black holes. They are black holes that are actively feeding. Black holes that are surrounded by hot glowing disks of material. Black holes that are radiating so much energy that they outshine entire galaxies. Tons of thousands of times brighter than the sun. Ton 618 at this point is 140 trillion times brighter than the sun. 140 trillion. The numbers are so large they stop meaning anything. They become just abstract symbols. But the reality is simple. Ton 618 is impossibly bright. It is one of the brightest objects in the universe. And its light reaches across billions of light years, and that is not all. Quasars often have jets, beams of particles and radiation that shoot out from the poles of the black hole, perpendicular to the accretion disk. And these jets can be incredibly powerful, incredibly fast. They move at speeds approaching the speed of light. They carry enormous amounts of energy, and they carve tunnels through the gas around them. They heat regions of space. They create shock waves. They sculpt the universe around Ton 618, and that energy and power pours out for millions of years, maybe billions of years. So Ton 618 at this point is not just a black hole anymore. It is a machine, an energy machine. A vast engine that is converting gravitational potential energy into light and jets and heat and power. And that power is shaping the universe around it. It is affecting everything nearby. It is influencing the formation of galaxies. It is preventing some gas from collapsing into stars. It is heating some regions and compressing others. And all of this happens because Ton 618 became a quasar. And the light from this phase is what we see now. When we look at Ton 618 through our telescopes, we are seeing this light. This ancient light. This light that left when Ton 618 was at its brightest. When it was actively feeding. When the jets were powerful. When it was the brightest object in the region, and that light has been traveling for 10 billion years to reach us. It has been redshifted, stretched, dimmed, but it is still recognizable. It is still carrying information. It is still telling us what Ton 618 was like, what the early universe was like, what it was like when the first quasars were turning on, and the transition from the dark ages to this quasar phase is important, because it marks a boundary. Before this, Ton 618 was invisible. After this, it was the brightest thing around. Before this, it was growing slowly. After this, it was still growing, but it was also radiating. It was also affecting everything around it. It was also changing the universe. And that change matters, because it means Ton 618 was not just a passive object. It was not just sitting in space waiting. It was active. It was powerful. It was influential. And maybe that is what makes Ton 618 special. Not just that it is massive, but that it is massive and active. That it is old and glowing. That it is a relic from the early universe that still carries information, still radiates energy, still reaches across billions of light years to touch our telescopes and teach us about the past. And that light that reaches us is precious, because it is a message, a time capsule, a letter from the early universe saying here is what it was like. Here is what it was like when the first giants were waking up. Here is what it was like when the darkness was ending and the light was beginning. And we can receive that message. We can decode it. We can learn from it. We can use it to understand where we came from, what the universe was like before the solar system formed, before Earth existed, before the conditions were right for life to emerge. And Ton 618 is one of the keys to that understanding. One of the witnesses to that time, one of the survivors, and its quasar light is its testimony, its story, its gift to us across the billions of years. But time moves forward. Even for Ton 618, even for the most massive black hole in the universe, time moves on and things change. The quasar phase does not last forever. Nothing lasts forever. Eventually the feast ends. Eventually the supply of nearby gas runs low. Eventually Ton 618 eats everything within reach. And when that happens, the brightness fades, the jets weaken, the quasar turns off, and Ton 618 becomes quiet again, dormant again. But this time, it is different. This time, it is old. This time, it is alone. Because the universe has grown around it. Billions of years have passed since the quasar was brightest. And in those billions of years, galaxies have formed. Stars have been born and died. Planets have coalesced. And some of those planets have become homes for life. And life has evolved, and civilizations have risen, and we are here, looking back, trying to understand. And Ton 618 is still there, still pulling, still existing, but now it is surrounded by a universe that is older, cooler, quieter, more empty, because the universe is always expanding, always spreading out, always becoming less dense, less hot, less full of life and energy. And Ton 618 finds itself increasingly alone. The nearby galaxies that it once dominated are now distant. The gas that once flowed in is gone, consumed, dissipated, and there is nothing left to eat, nothing left nearby. So Ton 618 waits. It waits in the darkness. It waits in the quiet. It waits for something that will never come. Because the universe is expanding too fast now. The galaxies are moving away too quickly. And Ton 618 will never be able to reach them. It will never be able to pull them in. It will be alone, forever, eternally, waiting for food that will never arrive. This is the loneliness of the ancient universe. This is the fate of the giants. They grow large in their youth. They consume everything nearby. They become massive and powerful and dominant. And then the feast ends. The supply runs out, and they are left alone with nothing but their weight, nothing but their gravity, nothing but the memory of what they once consumed, and Ton 618 will experience this. If it has not already, if it is not experiencing it right now, in the present moment, 10 billion years after its light left, Ton 618 might be dormant, quiet, slowly circling in an empty region of space, with no nearby galaxies to consume, with no nearby gas to eat, with nothing but time stretching before it, and time is a very long time. Because the universe is very old, but it is not old forever. It is very young compared to what is coming, compared to the deep future, compared to the timescale on which black holes exist. Because black holes are eternal, or nearly eternal. They last for incomprehensibly long times. They persist through eons that dwarf the current age of the universe, and Ton 618 will persist through those eons. It will outlive stars. It will outlive galaxies. It will outlive the era in which stars form. It will outlive the era in which planets exist. It will outlive everything. Everything except other black holes. And maybe not even them. Because there is something called the black hole era, and it is coming, far in the future, trillions of years from now, when stars have burned out, when galaxies have dispersed, when the universe has become so cold and so empty that normal matter no longer exists in any meaningful form. The universe will enter the black hole era, an era where the only significant objects left are black holes, all slowly evaporating, all slowly giving off Hawking radiation, all slowly fading away. But that fading is incredibly slow, incomprehensibly slow. It takes longer than 10 billion years, much longer. It takes trillions of years, maybe longer. And Ton 618 will be there for all of it, waiting, existing, persisting. And eventually Ton 618 will begin to evaporate, slowly, gradually. It will emit Hawking radiation. It will lose mass. One atom at a time, one particle at a time. It will get lighter, smaller, and the Hawking radiation will increase. The evaporation will accelerate. And eventually Ton 618 will disappear. It will fade away. It will become nothing. And that will be the end. That will be the final chapter of Ton 618. A slow fade into nothing. A gradual dissipation. A return to energy. To radiation. To the quantum foam from which it came. But that is so far in the future that it is almost impossible to comprehend. It is so far away that it might as well be infinity. It is a timescale so vast that it makes the age of the universe look like a blink. And Ton 618 will spend almost all of that time alone, wandering through empty space, with no companions, with no food, with nothing to do but exist. And that is a kind of eternity. That is a kind of infinity. That is what it means to be Ton 618, to be born in the first second, to grow for billions of years, to shine brightly for a while, and then to fade slowly, for trillions of years, into the deep, dark future. And maybe that is the real story. Not about how Ton 618 formed, but about what it means to exist for so long, what it means to be ancient, what it means to be eternal. Because Ton 618 is eternal, or nearly eternal. It will last longer than most things, longer than stars, longer than galaxies, longer than anything made of normal matter, and that longevity is a kind of power, a kind of immortality, and in that immortality lies a kind of peace. Because Ton 618 does not struggle, does not try, does not fight. It simply exists, and by existing long enough, it becomes eternal. And we are connected to that eternity through our light, through our observation, through our attempt to understand. We reach back through 10 billion years and touch Ton 618. And Ton 618 reaches forward through our minds and touches us. And for a moment, the ancient and the modern meet. The past and the present connect. And we understand something about what it means to exist in a universe so vast, so old, so empty, and so full of wonders. Ton 618 is one of those wonders. A relic from the beginning, a survivor to the end, a witness to billions of years of cosmic history. And so we come to the end of our story. Or not the end. Because there is no end. There is only continuation, only persistence, only the steady march of time forward into darkness. But we come to the place where we must stop talking, where we must let the silence take over, where we must let the universe speak for itself. And the universe speaks in silence, speaks in the deep dark quiet of space, speaks in the absence of light, speaks in the presence of gravity, speaks in the pull of Ton 618, reaching across billions of light years to touch our consciousness.